Where are those stupid ripple marks? Hey everyone, it's September 5th, 2022. We are at the type section of the Sturgeon quartzite up in the UP. You can hear the Sturgeon River in front of me. This is the first unit we're going to look at. This is a pretty white, clean quartzite. It is much older than the Baraboo quartzite. This is Paleo Proterozoic in age. It's the Sturgeon here is what we call it, but we now know stratigraphically, chronostratigraphically anyway, it's equivalent to at least part of the Lorraine Formation in Canada and of the Mesnard near Marquette. Now what I'm going to show you here is you see a lot of faces. You see faces here, you see cracks here and stuff like that. And looking at this, well, quartzite, it's very thick sedimentary protolith. You know, the parent rock was sandstone, which means it's bedded, which means you can get orientation. Well, these are bedding planes. And if you look, even at this outcrop, you can kind of tell with the way it's fractured that that's bedding. There are other places where there are ripple marks exposed to confirm this. I can't find them today. They might be too grown over. It is early September. Nothing's changing yet. So they might just be covered and I can't find them. But these are the bedding planes. So if you were to take strike and dip to get the regional area, this is what you want to do. And it's well exposed. It goes all the way down the road, comes back. But we're going to go east more. And we're going to look at some other units. But I just wanted you to know that this is the Sturgeon. It's not the oldest sedimentary unit here. There's another one underlying this that's actually really cool that we're going to go look at. We are stratigraphically below the Sturgeon, right below. This is the unit that underlies it. It's not continuous here. The stratigraphic equivalent of it in Canada is, but here it's not. This here is the Fern Creek formation, and I'm sitting on a rock, that outcrop that is near the bottom of it. You can see the bedding in it. It's actually foliation, but it follows bedding here. Now what's interesting about this rock I am sitting on is that it is some of the oldest glacial tillite on the planet. It stratigraphically is suspected to be equivalent to one of the glacial cycles of the Gauganda Formation, which is far thicker than this is here up in Canada. I forget off the top of my head how thick this formation is here. It's not too thick. We're talking maybe tens of meters, if that. It's not like the Gauganda, which is, you know, over 1,000 in those places. And what you can see here near the bottom is you can see all these inclusions, which are granites, granitoids, and they're just sandwiched. And you can see vague things like cross bedding and stuff like that. And you can see them here in some sort of matrix. This was a subglacial channel, river, something like that, depositing all this stuff. So this right here isn't the tillite, but we are going to go see some tillite. This here is subglacial water. Now the Fern Creek is over there. I'm going to take you to the contact. It sits right on top of the Archean rocks, which are, I don't know, off the top of my head, I'll correct it if I'm wrong, but they're about 300 million years older than this stuff. But this stuff includes most of that. I was just down there. As we move up section more, this is down section, you can still see a lot of clast. Come this way, because Sturgeon's that way. As you come up, you can see you start to get clasts of things like quartzite as well, here and here. There are even older quartzites that were incorporated in this as well. So you see now here we're starting to get more like what looks more like a till, if you will. You can see them there too. A lot of quartzite here. Some of this quartz is vein quartz derived from igneous rock. Some of it is definitely quartzite. I mean, you look at it under hand lens and it, oh no, this one's probably vein. But you look at it under hand lens and it definitely is granular It shows recrystallization. But so it's something you got to look for. Here, let me see if I can find one. This is probably vein quartz as well. Oh, here. This one is more than likely a quartzite, not vein quartz. You can see some relic bedding in it, and you look really closely. Hope I can zoom in enough. In the sun, you can see the shimmering. Those are the grains. So there's some quartzite here as well. We have been walking down section slowly, and from what you saw at the Sturgeon and the Fern Creek, you can see this stuff's pretty vertical. So you have a good cross section just walking east-ish in this case. Now here is the contact between that Fern Creek glacial stuff and of the underlying Archean gneiss. You see here, you see the gray of the Fern Creek, and we look closely at some things before I move to the Archean. I sort of say some things. The Fern Creek, these older tillites, see if you can see the shining off them, they are very much more sandy than modern tillites. Even though the Gauganda kind of does look like modern tillite in places, but here this is a lot more sandy. You do have some finer silts and clays, but it's very sandy material. And here it has been metamorphosed as well. So here you can see a deformed clasp to demonstrate that. You can see it's phyllite-like on the surface here. So we do have metamorphism here. And this is just a fracture that became mineralized with some reddish quartz. Here you can see a lot of small clasps oriented along with bedding. So we know this stuff was transported. They're a little more rounded. This part is probably water lane, but you look around more, you see that switch between water and ice lane. You do see drop stones and things like that here. So we're pretty confident that that's a glacial deposit. You look here, and now we're on the gneiss, the Archean stuff. And you can see the contact really well right here because it's been weathered. Now, if you ask a fraternity geologist what a paleosoil is, they're going to tell you it's a buried organic soil because they're going to think in terms of modern glacier. There's nothing on land to make topsoil then. So if something was exposed to the surface, any soil development is technically chemically induced or mechanically induced. So here you have a very thin paleosoil on top of this gneiss. That's why it's so rusty and red looking. And here we do have, although we're looking at this vertically, we do have some initial dip here. The bedding of the glacial stuff is more or less like this, which does not line up with this orientation. That tells us we have some hills and valleys around here. Probably not too high and low, but enough to create some initial dip on some of these rocks with some paleo topography. Now the river almost, but not quite, separates the Archean from the Paleo-Proterozoic Fern Creek and Sturgeon. You can see the red gneiss down there, and the contact with the Fern Creek runs about where the bend in the river right there is. But you look back there, and that's not gneiss. That's something else. Now, I forget off the top of my head what it says on the map. This area has been mapped. I was hoping the water would be low enough to where we could cross and I could go look at it. But that's one of two things just for me looking at it. If this was a virgin area and I saw all this tillite and the quartzite and I hit the contact here and found it and I'm trying to trace it and I can see gneiss here, I can see gneiss down there, and then I don't see it. Well, that obviously can't be tillite. That would mean this is a huge boulder of gneiss. And no, that's not really, that's not a thing. So there's no glacier thick enough to move something that large ever that we're aware of. So I would hypothesize one or two things, and I can confirm that this is not a class. I can tell you, it's all granite, way down there. I've been way down there, or granitoid, and nice metamorphic granitoid. So that is either some sort of later intrusive dike that gray rock there, it's probably igneous. You don't see any clasts in it, so that's another thing to tell you. It's not Fern Creek. Or it's some sort of a little bit of a greenstone within the gneiss. I don't really know though. So I'll relook at the map and see if the map clears it up, and I'll let you know here what it actually is if it does. You can tell this paleo topography because my knee is now on that weathered zone between the gneiss and the Fern Creek, and if I follow the strike, I end up in Fern Creek, and there's Fern Creek there as well, and Fern Creek there. So what happens is this was some sort of paleo hill. Now, you gotta remember, this stuff would turn almost vertical. So this would have been level flat lying this way. I'm still on the hilltop here, just not as its original position, and that does go down there. So that's one way you can kind of use modern topography to help delineate your units. Like I said, there are no expressive faults right here, so it has to be paleo topography. So this stuff, like I said, is about 300 million years older than that stuff, give or take. So we had a lot of missing geologic time. To put that in perspective for you, that amount of time is about from today to the formation of Pangea. People who study the Fern Creek generally don't think about it. And that's what I love about the Precambrian, because in a lot of it you can do that. You can put your finger on 300, 400, 1,000 million years of missing time pretty easily throughout it. And people like to talk about the great unconformity. Well, there's several great unconformities in a stratigraphic record. It's just the one most people are familiar with is between the Precambrian and the Phanerozoic, but that's a generic concept that no longer exists. We know that the great unconformity isn't global. There's places that are continuous deposition between the Precambrian, the Neoproterozoic, and the Cambrian. So it's not global. And there's other places where you have what's equivalent to, could be called great unconformities. As a matter of fact, the Grand Canyon is 2 of them. So it has one on top of the really old rocks, and then it has Grand Canyon supergroup, and it has one on top of that. So yeah, so it's all a matter of what scale you're working with.